Hey guys, good morning or afternoon whenever y'all decide to get up. All right, let's get going. 11.5. Today we are adding and subtracting radicals. All right, adding and subtracting radicals. You're not really adding and subtracting. You're not really adding and subtracting. Isn't that nice? What you are doing, you're going to combine like terms. Y'all have been doing this for 2 years now. 2 years now, multiple times during the year. So this stuff isn't going to be quite as bad. It's taking what we've been doing since the beginning of this chapter and just applying all the, every time we combine like terms, then, you know, like all the a squares or all the 2c's and stuff like that. Okay, so anything that's like terms, that's what you're going to be combining. And when it says like terms for this stuff, we're going to be combining like radicals. Okay? All right, so for example, the square root of 5 plus the square root of 2. Are these the same? No. Can't be combined. The square root of 5 and square root of 2. Not the same radicand. Now remember, the radicand is that number inside the radical sign. Okay, that's your radicand. Okay? Anyway, I'm sorry, I got distracted because I can hear Owen sitting there making a joke about radicand and radicant. Yeah, I know he'd be making that joke, and y'all do too. Anyway, I just had that image of him making that joke. Okay, sorry, I'll get back on track. All right, so you cannot combine these two because they're not the same. I'm still laughing. Because when you do that all the time, you always make some little joke. Okay, and I know you would be doing that. So if you are, you need to like message me your joke or put it in the group text because you know you're sitting there making the joke in your head. Okay, so what about if I do this? Four times the square root of 3 plus 2 times the square root of 3. Do they have the same radicand? Sorry. Yes, they do have the same one because 3 is the same as 3. So if I cover up the 2 and the 4, notice those are the same. So we can combine those. We radicand. Anyway, what's 4 plus 2? 6. And the square root of 3? We don't do anything with. We just bring it over. Okay, see, that's not bad. So if they have the same radicand, then you just add the number on the outside, which is what we did, and then bring over the square root. That's the same. That's it. Okay, so steps on how to do this, because you know they're not all going to be that easy. All right, so step 1, simplify each radical. Okay, so step 1 is simplifying each radical. Basically like factor tree, you're getting prime numbers. Etc. Okay, y'all been doing that. Y'all even had an IXL on that. All right, number 2. Combine like terms. And that's it. Okay, so let's do some. Because some of them are going to get hard. But after I do several, I'm going to do 1, 2, I'm going to do like 2 of these. And then I only have 3 from the book that I'm going to do. Then I'm going to set you free. So if you have questions when you're doing this, contact me anytime. Seriously, I'm there for you. If you're like, Miss Rogers, can you do another odd number for me, blah, 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 blah. And Miss Rogers, am I doing this right, etc., etc., please contact me. Okay, that's what I'm here for. All right, so let's do another example. Square root of 45 plus square root of 18 minus square root of 5. Okay, so that's a little bit crazy. All right, so here we go. These are not simplified. This is prime, so it's all good, right? All right, but these two are not, so we're going to have to do the factor tree over here. All right, so 2 numbers, when multiplied, give you 45. 5 times 9. And then 3 times 3. I'm just going to do it in black ink. Sorry, guys. Okay, so then, so we got that. Excuse me. So we're going to write 3, cross out, times 3, times 5. It's separate. Okay, so what's my root? Your root is 2. Remember, if there's nothing there, we assume it's a 2. So I'm going to go back to my 45. See, did the factor tree? We're simplifying it out. And I'm circling my pairs of 2 numbers. Remember, this goes on the outside. And what's left over goes on the inside. Okay? So notice I've turned the square root of 45 into 3 times square root of 5. Okay, so now let's do 18. I'm going to do my factor tree. I have 2 times 9. 2 is prime, and then I have 3 times 3. So 3, cross out, times 3, cross out, times 2. My root is 2 again, and also, by the way, you can only combine them if they have the same root as well. Circle my pair, and that's my leftover. So I have plus 3 on the outside, 2 on the inside. Now, can I factor anything out of this? No, it's prime. And simplified. There's nothing more we can do. So I'm just bringing it down. Okay, so I'll cover that up. Here's my new math sentence, okay? What was the original thing? You can't, well, step 2 is, we did step 1, we simplified everything. Step 2 is combine like terms, like radicals. This and this are the same. Remember how I used to circle them? With the sign included. Remember that? And then like this, I would box. Remember this, guys? Including the sign. This is not the same as these. Notice that's a 2. These are 5s. So I can combine them. 3 times square root of 5, cross out, minus square root of 5, cross out, plus 3 times square root of 2. I'm combining my like terms and then just bringing that on down. So, what would this be? If, question, let's see, we'll call on Christian. Christian, if there's no number on the outside here, what can we pretend is there? We can pretend there's a 1 there. So, if the radicals are the same, 3 minus 1 is 2, and then we just rewrite square root of 5. This cannot be combined with anything, so I just bring it down, and there's my answer. So if you're like, okay, wait a minute, I need to go back over and look at this again. Feel free to rewind this part, this example right here. Go back over it again. Again, we simplified, rewrote the new one each time. Don't combine them or anything. We're doing each one. Brought this down because it can't be simplified. These two are like terms. So 3 minus 1, the imaginary 1, is 2. We just bring down our 5. And this, we just bring down right there. Okay? All right. Again, rewind it if you need to see it again. All right, next example. This one's kind of weird, okay? This is a hard one. But I purposely gave you a hard one. Because if you understand this, then you're good to go for all the easy ones. All right, so I have a negative 8 times the cube root of 5 plus 9 times cubed root of 40 minus 2 times the cube root of 135. Yeesh. Okay, y'all ready? All right, so the first step, you remember, number 1 is to simplify each radical. You know, your factor tree, getting prime numbers, blah, 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 blah. All right, so let's look at the first term. This negative 8 times the cube root of 5. All right, can we simplify that any? No. That 5, there's nothing more you can do to that. So we're going to leave it alone for right now. This 40 is what you're looking at on this next one. This 40 is what you're looking at. We need to do a factor tree because it is not factored out. Watch this 9 though. Okay, we're going to be doing something with it later. But when we do the factor tree, we're going to only focus on the 40, but we will be utilizing that 9 later. So pay very close attention. All right, so I'm going to do my factor tree of 40. I'm going to be rewriting all this down here. Okay, so be ready. Oh yeah, I will. Okay, so 2 times 20, circle my prime number. 2 times 10, circle. 2 times 5, circle. So remember, we're only focusing on that term right there in that 40. Okay, so I'm going to rewrite this. 2 times 2 times 2 times 5. Okay, what's my cube root? That's my cube root. What's my root? It's 3. Notice they're all the same because you can't combine when they're all those other weird things. Okay, so it's 3. So I'm going to come over here and I'm going to circle my 3. That's my leftover. So I'm going to go ahead and I'm going to rewrite this down there. Negative 8 times the cube root of 5. I'm going to rewrite this one, but watch how I do that. It's plus, see that 9? Remember this part that I circled goes on the outside, yes? It's going to be 9 times that 2. So 9, see the 9, times this 2, times cube root, the leftover is 5. So I'm bringing this whole thing down. That 2 is going to go there, and I'm bringing that 5 underneath there because it's your leftover, right? All right, so we're going step by step. Now we're doing this term. So I got to do my factor tree of 135. I can do 27 times 5, 3 times 9, and 3 times 3. All right, I'm going to write it down because remember, this is separate. It's not like when you're multiplying and you combine it all. So 3 times 3 times 3 times 5. All right, again, my root is 3. So I'm circling my 3. This is my leftover. This is going to go on the outside. That's going to go on the inside. Notice that 2. So I have minus. I'm bringing that 2 down, just like I did that 9. I'm bringing that 2 down, That 3 is going to go right here. It's going to be multiplied. Then I do my cube root of 5 goes there. So that 2 goes right there. Again, you may need to rewind this and take it all in again. This is the best part about being home, is when I'm at school, it's kind of hard to do that. But you can on your own. So notice I take that 2 and that 9, bring it down. The group, whatever I circle, is going to go out on the outside, and I'm about to multiply it. The leftover goes on the inside. All right, so let's go ahead and multiply this stuff. This stays the same. All right, this 9 times 2, 18. And this stays the same. Minus 2 times 3, that's 6. And this stays the same. All right, remember now, step 2, we combine like terms. We've simplified. That's our simplified part. Now we combine like terms, and check this out. Look at the radicands. They're all the same. So we can combine all of these. In fact, I'm going to just go ahead and circle it lightly, including the sign. All of these can be combined. They're like terms because all the radicands are the same. So let's go ahead. Let's do those two. What is negative 8? Remember, we don't even have to mess with the radicand now. We're just looking at that outside number. Negative 8 and positive 18. That will give you a 10 times the cube root of 5. And I'm going to rewrite my problem. Now I can combine these two. What is 10 minus 6? 4. And I rewrite my problem. That part. Okay? So notice, negative 8, like Christian, you're going to sit there and go negative 8 and 18, that's 10. 10 minus 6 is 4. And then just bring down your others. Okay? So remember, I'm rewriting my problem. I'm combining all these, and I end up with this. Rewind the video and look at it again if you need to. Okay? When you're doing these problems, I've done an example of all of them, something similar. So the best part is, unlike my students in all the years in the past, you can sit there and say, oh, it's one of these problems, and just have my final work sitting on your computer screen or TV screen while you're working that other one, that new one. Same with right here. You've got this kind, you've got this kind, and I'm about to do 3 more. Okay? So you've got these examples. Please have them on your screen while you're working. So let's do some examples. I'm only going to do 3. Page 454. Numero uno. All right, let's go. So square root of 3 plus 5 times square root of 3. All right. Let's see. Haley, if there's no number on the outside here, what do we pretend is there? 1. Are these the same radicands? Yep, they're the same. So we can combine those. They're considered like terms. Okay, so 1 plus 5 is 6, and we bring over that square root of 3, and we're done. All right, 3. Square root of 3 plus 4 times square root of 2 plus square root of 3. All right, we have to combine like terms. First, are all these simplified? Yes, they are. There's nothing I can do to the 3 and 2. It's prime and it's simplified as much as it can. So now we're just going to combine our like terms, and these two right here are our like terms. All right. If I do not have a number in front of that radical sign, Alexis, what do I pretend is there? A 1. Okay, so these two I can combine. 1 plus 1 is 2. So 2 times square root of 3 plus, and then this, it has nothing to combine with, so I'm just rewriting it, and there's my answer. Okay, so we combine our like terms, that gives us this. Whatever's left over, just like we've always done this year and last, we just rewrite it. All right, and the last one I'm doing, 5. So I did some of those other hard ones. Now again, if you have questions, you need help, let me know. Let's see. Yeah. All right. Every year I've only done up to 5, but if hey, I can change. So if you need another one done, you let me know. I'll even FaceTime you and we can do it together. Okay, so here we go. First step is we need to simplify everything. This one is simplified because that 2 is prime, doesn't need to be simplified, but this 8 is not. So I'm going to do the factor tree over here, and I have 2 times 4 and 2 times 2. I'm going to write it 2 times 2 times 2. What's my root for both of these? Deja. Root is 2. So, Tanya, how many 2's do I circle? 2. So I'm rewriting this. Remember, this goes on the outside, that's on the inside. So that's 2 times square root of 2. And then I'm bringing that down because there's nothing I can do to it. So here's this one and here's this one. All right, now the second step is to combine like terms. That 2 is the same, therefore we can combine those. So what we do is 2 plus 3 is 5, and then rewrite the square root of 2. That's it. So this isn't too bad. If you are still confused and need me to do some more odds, I'm all yours. If you have questions during your homework, please do not hesitate to contact me. So page 454, you're doing numbers, hold on, two through 12 even. That's all I'm going to have you do. 2 through 12 even. I think 1, 2, 3, 4, 5, 6. Are you kidding me? 6? I'm going to challenge you. How about just a 22? No, wait. To 12 even, and then 18, 20, and 22. All right, so that's, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 problems. I'm not even going to give you 10. I think you got it. This is due Wednesday, okay? And I will be doing some IXL for y'all. It's going to be due Tuesday, April 28th. You got a whole week to do it, and I don't think I've got that many for y'all, so that's not bad. You're going to have a test next week on Wednesday, April 29th. How to look at my board. Okay? So guys, seriously, let me know if you're having any trouble. I'm all yours. Bye.